The second part of partial pressures has to do with a lot of experiments of collecting gas over water. So all water has a certain amount of vapor pressure until it freezes. And so but water, like this tube here, with markings of volume, is a very common way of measuring the volume of gas that's produced. So you do an experiment over here. This is hydrogen plus hydrochloric acid, and these gas bubbles being released is hydrogen gas. And so it bubbles through this tube and then comes up into this tube, displacing the water back into the beaker, and you can measure how much hydrogen was formed. Now, the water's at 19 degrees, so it tells me that the partial pressure of hydrogen is 752, and the partial pressure of the water, because water pressures are known by temperature, was 17 millimeters of mercury. And so that's almost our 760, it's actually just over 760, so this is over 1 atmosphere in pressure. So here's a table of vapor pressures at different temperatures. And if your temperature is not listed, say at 22 degrees, you can take the average of these two. We expect that it's a linear response between temperature and temperature there. Pressure and temperature is linear. So here's an example of a problem. So we're going to decompose ammonium nitrate and form water and nitrogen gas. And this is one of the ways that they prepare normal nitrogen gas. So it wants to know what the mass, how many grams, so mass of the NH4 NO2. If I have a volume of 4.0 liters and a temperature of 26 degrees C and a pressure of 0.965 atmospheres. Now, this is the pressure of the nitrogen, or this is the total pressure here. And in order to do this problem, I need the I just need the pressure of nitrogen. This is also a stoichiometric problem because I'm given information about nitrogen and asked about ammonium nitrate. So I'm going to do the same problem I did in the earlier video. I'm going to write down the reaction. And I'm going to put the information. So this is what we want to know here, okay? And we're told that we have 4.0 liters, we have 26 degrees C, and 0.965, well, actually that's not the pressure of nitrogen, we have to find the pressure of nitrogen. And so we'll start out by doing that. If we go back to the previous slide, this is at 26 degrees, and you will notice that at 25, it's 23.8, and at 27 it is 26.7 or 26.7. So when I average these two together, I get 25.3. Oops, that disappeared. 25.3 millimeters of mercury. So all I did was just take these two numbers, add them up, and divide by 2. So my pressure of water, I'm not having luck with this pen today, we just said was 25.3 millimeters of mercury. Before I subtract, they need to be in the same unit. So I'm going to go ahead and change this one to atmospheres by dividing by 760. And that gives me 0.03322 atmospheres. So that means that my pressure of nitrogen is the total pressure, PT, minus the pressure of water. So I have 0.965 minus 0.0332 to give me 0.932 atmospheres. So now this is 0.932 atmospheres. So now it's basically just like a stoichiometry problem that I did before. I need to find the moles of nitrogen, relate that to moles of ammonium nitrate, and then find the mass of ammonium nitrate. So steps. So the first thing we're going to do is we're going to use the ideal gas law, PV equal nRT. My pressure is 0.932. My volume is 4.0. N is what I'm trying to find. This is N of nitrogen. R is 0.0821. And T is, I didn't do that yet, plus 273 gives me 299 K. So 299. When I multiply these two values together, I get 3.727. When I multiply these two values together, I get 24.55 N of N2. So 3.727 divided by 24.55 is equal to N of N2. So N of N2 is 0.1518 moles of N2. Now, like I said, that's nitrogen, but I'm asking about ammonium nitrate, so I have to do the molar-mole ratio. I expect you to show this in this example that it's 1 mole of N2 over 1 mole of NH4 and NH4NO2 gives me again that 0.01518 moles. This time it's NH4NO2. So I want you to show me this step even if it's 1-to-1, because for the test I will ask for partial credit. This will be worth partial credit even though that is the same answer. So you will lose the partial credit for not showing this step. And then to find the mass of NH4NO2, of course I need the molar mass. So let me go over here. Molar mass is going to be 14.01, that's nitrogen, plus 4 times 1.01, that's the hydrogen, plus another 14.01 for nitrogen, plus 2 times 16, which is oxygen. So that gives me a molar mass of 64.06 grams per mole. So this is going to be the oops, I wrote this wrong. I have it written on the line before correctly. 0.1518 times my molar mass of 64.06, and this was in chapter 3 that we learned how to do this. It gives me 9.73 grams of NH4NO2. So if you have forgotten how to go from moles to mass, you can go back to the YouTube channel for chapter 3, and I think it's 3.2 shows you how to do these calculations. And that is the end of this video.